In this video, I'll show that machine learning can achieve greatness with understanding natural human language, but only when there's labeled training data. Here's another impressive accomplishment made possible only with the right labeled data. In 2011, IBM's Watson computer defeated the two all-time human champions on the TV quiz show Jeopardy. I'm a big fan. This was by far the most amazing thing I've seen a computer do. More impressive than anything I'd seen during 6 years of graduate school in natural language understanding research. Here's a 30-second clip of Watson answering 3 questions.
Nickname's 800.
Appropriately enough, this New York metropolis is Bison City. Watson.
What is Buffalo?
Yep.
Magical Mouse Tour for 400.
Itchy, the mouse, and Scratchy, the cat, starred in Skinless in Seattle on a show within this Fox show. Watson.
What is The Simpsons?
Right.
Familiar sayings for 400.
Familiarity is said to breed this from the Latin for despise. Watson.
What is contempt?
Correct.
To be clear, the computer didn't actually hear the spoken questions, but rather was fed each question as typed text. But its ability to rattle off one answer after another, given the convoluted, clever wording of Jeopardy questions, which are designed for humans and run across any and all topic of conversation, feels subjectively to me like the best intelligent-like thing I've ever seen from a computer. But the Watson machine could only do that because it had been given many labeled examples from which to learn. 25,000 questions taken from prior years of this TV quiz show, each with their own correct answer. At the core, the trick was to turn every question into a yes-no prediction. Will such and such turn out to be the answer to this question, yes or no? If you can answer that question, then you can answer any question. You just try thousands of options out until you get a confident yes. For example, is Abraham Lincoln the answer to the question, who was the first president? No. Is George Washington? Yes. Now the machine has its answer and it spits it out. And there's another area of language use that also has plentiful labeled data, machine translation. Machine learning gobbles up a feast of training data for translating between, say, English and Japanese, because there are tons of translated texts out there filled with English sentences and their corresponding Japanese translations. In recent years, Google Translate, which anyone can use online, swapped out the original underlying solution for a much improved one driven by deep learning. Go try it out. Translate a letter to your friend or relative who has a different first language than you. I use it a lot myself. On the other hand, general competence with natural languages like English is a hallmark of humanity and only humanity. There's no known roadmap to fluency for our silicon sisters and brothers. When we humans understand one another, underneath all the words and somewhat logical grammatical rules is general common sense and reasoning. You can't work with language without that very particular human skill, which is a broad, unwieldy, amorphous thing we humans amazingly have. So our hopes and dreams of talking computers are dashed because unfortunately there's no labeled data for talk like a person. You can get the right data for a very specific, restricted task like handling TV quiz show questions or answering the limited range of questions people might expect Siri to be able to answer. But the general notion of talk like a human is not a well-defined problem. Computers can only solve problems that are precisely defined. So we can't leverage machine learning to achieve the cohesive and conversational computers we see in so many science fiction movies like the Terminator, 2001's evil HAL computer, or the friendly, helpful ship computer in Star Trek.